Let's talk about the path with minimum effort. So basically, you are given 2D array, and then for every single cell represent an integer, and then you have to find out the minimum difference between the consecutive cells. So in this one, in this example, you can actually go this way, you can actually go this way, and you can also go this way. So you have to find out the minimum absolute path. So the minimum absolute path is what? This is 2. The minimum between these two cells is 2. And this is 2, 2, 2. And this is 3. This is 0. This is 0. This is 1. So even though this path has 1, 0, 0 so far, but the last cell is actually 3. The difference between these two cells is 3. You are no longer allowed to use this. You want to find out the uh the minimum difference. I mean, let's be honest, the minimum difference between two consecutive cells. So you can actually go up, go right, go left, go down, and then you have to find out is there a path that can actually give you the minimum difference. So in this one, the minimum difference is actually 0, right? You're not adding, you're not deleting, right? So you don't traverse like this, right? This doesn't actually work. So here we go. So what you actually need to do is I need to create another DB. Let's store the difference of the two cells. And I have a priority queue, and this priority queue stored in array, and this in array stored in x, y, and current value. And this is pretty much it. So let me code it. So height command and equal to height as 0 length, and then I need to create db m by m, and I need to create priority queue storing in array pq is equal to new priority queue int, and I have stored two. Oh, I need to sort this pq based on the value. So it's going to be ba2 minus pq. So in this pq, I'm sorting the in array, right? And this array store x coordinate, y coordinate, and value. So the value represent the current um, maximum maximum value for this one. So if you have uh, the difference value which is less than the current value, then you can update. All right, there we go. So I need to add the current position 0, 0, 0 into it, right? For the first cell on the top left, you don't need to find out the minimum difference. When you go on the right, go on the bottom, you need a current sub value, but in this case you don't need it. So while PQ is not empty, you can traverse, right? So I need to pull from my PQ. So I'll say, okay, what's the current coordinate, right? So the current coordinate, I'm gonna use an x1 just in case, because I will use in y2 later. So y1 equal to no no 1, and value equal to no 2. So if the current position x1 is actually equal to what? It's actually equal to bottom right, which is a -1, and also what? y equal to m minus 1. I can actually return value, right? Then I need to traverse 4 direction, right? And I forgot. I need to create a 2D array for direction. -1, 0, 1, 0, 0, 1, 0, -1. So I need to traverse 4 different directions. 4, in direction, and then I need to have a position for x2. This is going to be the next point based on the x1 and y1, right? Die 0 plus x1 y2 die 1 plus y1. So at some point x and y, x2 and y2 will be out of bound, right? If you just keep adding to the left, you will definitely out of bound, right? If you keep adding on the right, you will definitely get out of bound, right? Because I didn't set a limit. So if x2 less than 0, or x2 is actually equal to what? M, or y2 is actually equal to less than 0, or y2 is actually equal to M. I need to ignore, so I continue, right? So I need to find a current maximum. Let's be honest. So I need to find out the current maximum between these two cells and the current value, right? So I'm going to call weight. So max value, and it's going to be height at x2, y2 subtract by x1, y1. So the difference between 2 points, right? In the original DP, right? Then I need to then I know, okay, this is the weight, okay, and this weight is considered like the current maximum between the current cell value and the difference between 2 points, right? But I need to find out the minimum, right? So if the DP at x2, y2 is actually what? Greater than the weight, right? I can update, right? And if DP does not assign any value, right? Does not assign any value, I can also update, right? So when I have to update, I will say x2, y2 is equal to weight, and then I need to use this benefit to find out another benefit. So maybe there's another way that I can find out which is shorter and smaller, right? I need to just add the PQ, just making sure, right? It's going to be x2, y2, weight, right? And at the end, I will just return what? Return -1. This is because I need to return something, right? But somehow, I will definitely return something when I go on the bottom right, right? And let me run this case. So I didn't say where's the 27. 27 is what? Oh, I don't know what's wrong with this one. All right, another one. Oh, this is in array. Okay, what else? This is y1, right? Sorry for the mistake, but whatever, man. All right, let's submit. All right, I got a solution wrong. This is because what? How do I know? How do I know? Is x2 y2 is always greater than x1 and y1, right? How do you know is 2 minus 8 or 8 minus 2? This is not allowed, right? So what does absolute mean? You can use method in this case, right? So I'm going to submit right away. I don't care. Yes, I passed. So this is a trick, right? And I almost forgot. So all right, here we go. So let's talk about time and space for this one. For every single point, how many points in the in this metric? So I'm gonna say points. There are m times m, right? M. So how are you going to have the worst case for the time complexity? It's going to be what? M times m log m times m. So that this is the worst case, right? And how about the space? Space is what? All of m times m, and this is constant, and here we go, this is constant. So this is pretty much a solution. So time and space, and this is a quick note, time and space complexity. And here we go. So I will see you next time. And this is a little bit challenging for sure. And due to the constraint, right? And I will see you next time. Bye.